Today in lab, you will use the ideal gas law to calculate the gas proportionality constant R.
When temperatures are high and pressures are low, gases behave according to the ideal gas law.
This law relates temperature, pressure, volume, and number of moles with the proportionality constant R when they are under ideal conditions.
So we need to measure those parameters to be able to determine R. Today's reaction will produce oxygen gas, which will need to be contained and measured.
We will create a closed system with this equipment.
Start by attaching the ring clamp at the top of the stand. Next is the 3-finger clamp. Your equipment drawer may also have this style of clamp.
Finally, the burette clamp attaches to the back side of the stand.
The bulb and burette apparatus can be found on the cart.
The top of the burette is passed through the top of the ring clamp. The bulb comes to rest in the ring, and the burette is clamped in such a way to prevent the hose from crimping. Use the sink to help give the hose more space.
Attach the large test tube to the 3-finger clamp. Make sure it is at a convenient angle for adding reagent during the experiment.
The small stopper goes into the top of the burette, and the large stopper will go into the large test tube. Adjust location of test tube if the hose doesn't reach.
Now fill the bulb with water. You will have to move the bulb to encourage the air bubbles to escape the hose. The water should reach the same level in the burette as the leveling bulb. You may need to add more water to get the bulb half full when lined up with the 0 milliliter of the burette.
Check for air leaks by placing the stopper in the large test tube and lifting the bulb. The meniscus will only bounce a little in the burette if it is airtight. If the water level moves a lot, there is an air leak. Your lab instructor can help if you can't find the air leak.
The apparatus needs to be airtight, so you can collect all the oxygen gas formed. Any leak will lower the volume of gas collected. This apparatus is ready for the experiment.
A decomposition reaction of hydrogen peroxide takes place in the large test tube. This produces oxygen gas collected in the burette. Your lab instructor will tell you the concentration of the hydrogen peroxide solution. From this, the moles of gas produced can be calculated.
Follow the directions in the lab manual to prepare the pipette. And then measure 3 milliliters of hydrogen peroxide solution into the large test tube. As always, be careful when attaching the pipette to the pump. If you need more detailed instruction, see the how-to pipette video. And remember, never pipette directly from the stock bottle.
Adjust the angle of the test tube to nearly horizontal while keeping the peroxide solution in the bottom. This allows us to transfer the reaction catalyst into the test tube and close it before starting the experiment.
Baker's yeast contains the enzyme catalase, that is the catalyst. A little petroleum jelly is placed on one side of a small magnet, and it's rolled through the yeast. The next step is tricky and requires coordination and cooperation between partners. Check. Hold the large magnet on the outside while gently placing the small magnet inside the test tube. When it catches in the magnetic field, I'll stopper the test tube. Once closed, the bulb is leveled with the burette. It looks like the first burette reading is 0.05 milliliters.
Watch the How to Use Graduated Glassware video if you need help reading the burette.
When everything is set, release the large magnet and use it to stir. If the magnet drops before everything is set, clean up the test tube and magnet and reset.
Jenny has to adjust the bulb for every 10 milliliters the water level in the burette goes down.
The water level hasn't changed in a while, so it looks like the reaction has finished. To make sure that the pressure inside the burette is equal to the atmospheric pressure, we have to keep the water levels the same. Adjust the bulb water level to align with the burette water level, then take the final burette reading. I read 28.00 milliliters.
This gives us a direct measure of the volume of oxygen gas produced, but we take the temperature of the water to get an indirect measure of the gas temperature. Never leave the thermometer in the bulb as it could easily break.
Now we are ready to reset for our next trial. Empty the test tube into the sink, but pour through a paper towel so you keep the small magnet. Wash and dry the test tube and small magnet between each trial.
After all 3 trials, you can rinse the pipette and return to cart. Lift the bulb and burette to pour out water into the sink. Return to the cart as well.
The pressure in the burette comes from oxygen gas and water vapor since the gas was collected over water. When the lab instructor tells you the atmospheric pressure, you can figure out pressure from water vapor and the pressure of oxygen gas.
Pay close attention to the units used for each calculation. You will have pressure, temperature, volume, and number of moles.
With those, you can get the R constant.
Using the gas collection apparatus can be tricky.
But once you get the hang of it, things should go quickly.
Have a great lab.